could you tell us just about the glider project in general?
Well, one of the areas we really wanted to focus on at the 8th grade level was aeronautical engineering, and we thought using white box learning, we use it for a lot of our virtual simulations, and since we had that application, we thought we'd go ahead and try to implement it at the 8th grade level. And gliders, I think, is a really good entry level to kind of lay a foundation if they want to go into that sort of thing, especially at the CAPS program.
Okay. So next, could you tell us what problems you were having with that project?
Well, the biggest problem was we found that a lot of our, in the white box learning software where they get to do the air show, a lot of their virtual times didn't match up with the real world times. And, I personally don't have a great background knowledge on aeronautical engineering, so I really didn't know what the problem was. So that's kind of why I try to collaborate a little bit with Mr. Sutcliffe in the summer. And when he brought up this project, I was definitely all about making sure we tried to fix this problem. And again, I really do appreciate everything that you guys have done thus far to fix the problem. So
awesome. Thank you.
All right, Joey, what have you done for this project so far?
My main task for this project has been designing the planes in white box learning. This program is an online program that allows us to design the planes and then test them online. But when we went to test them in real life, we found some flaws with the program that didn't necessarily match up. When we looked at the shape of the wing, it said that the curved wings would work much better on the program than they really did in real life, and we found that the straight line planes work just as well, and if not better in some cases. Another thing we looked at was the type of wing. There's 3 types of wings. There's the flat wing, the dihedral, and then polyhedral wings. Depending on how you launch it, it has a different effect, but white box learning said that the polyhedral and dihedral would work a lot better. Whereas in real life, we found that there's not really a huge significant difference, and we found that the flat wings work a lot better sometimes too.
Okay, so this is the gliders program for white box learning. As you can see, it gives you a basic plane design to start off with. What we can do with this is we could go in and alter different aspects of the plane. For instance, this is changing the wings, and what this does is it changes the optimization. The optimization is what allows us to tell if the plane will be able to fly or not. And you want all these green bars to be in the green. And if they're not in the green, it won't be able to fly.
All right, Connor, what have you done for this project?
Okay, so I specifically worked with the assembly of planes and seeing what you could do when you were assembling the planes to get the best results out of them. And so one of the very first things we looked at was glue, because we knew that we were dealing with middle schoolers, specifically 8th graders, and we didn't know if it'd be a smart idea for them to use the glue we used, which was a really fast drying CA glue. And so we looked at Elmer's glue and 24-hour drying wood glue, and both of those worked okay, but just the time it took for them to dry was too long for us. We didn't want to have to wait a day after gluing our planes. So we stuck with the CA glue, but it works fine for the kids to use either. So actually, I think Mr. Riley was just going to glue the planes for them with super glue. But then the next thing we looked at was sanding. The program Whitebox told us that sanding the wings down would work really well for the planes, it would help it fly better and farther. But we found out that it actually doesn't do anything. So we decided that they don't need to sand it regardless of what the program says. And then the next big thing we looked at was the wing placement. So we looked at if the wings could be placed off center, how well it would still fly. And we found out that even with the wing placed a 2 or 3 centers off from the center, the plane still flew pretty well. And then lastly, we looked at how rough the cuts could be. We cut a couple random circles into wings and stuff, and they still flew pretty well. Obviously, the ones that were kind of busted up didn't fly as well as the good planes. But all that kind of just points towards it was pretty lenient, what you could do when the kids were building the planes to have them fly well. Okay, Matt, so what have you done for this project?
Alright, so basically what I've been working on this project was building the launcher that we've created. So first things first, we decided what material we should use. I came up with wood just because it's lighter than metal, cheaper than plastic, and easier to use as a whole. So after we got the wood, I decided I should find the correct dimensions for it. When I found that all out, I decided, alright, next thing's next, we should get the motors. So when I found which motors we would use, which had the correct power and that sort, I assembled the whole motor or the whole launcher together. We came up with an issue of the motors were not fitting into the launcher correctly. So I decided, that I should build some custom mounts. When I built those custom mounts, we just screwed them onto the launcher and screwed them onto the motors, and we would go from there.
Alright, Ethan, you want to tell us what you've done for this project?
Yeah, so I worked on the electrical components aspect of this, hooking up our motors to the launcher. We started off just using a 12-volt battery and just hooking them up straight from there. That was overheating them as well as spinning them too fast for the planes to go through, just destroying the planes. So Mr. Sutcliffe suggested that we make a variable speed controller. So what that meant was that we had to get a potentiometer, hook it up to a TNC microcontroller, and then attach that to the whole setup. So I worked on soldering all those components together. Had some trouble there. We had one of those actually burn out. Some different issues with that, but eventually we got that taken care of. And yeah, now we can change the speed and it works.
All right, so I guess we'll start off with some questions from the audience. Yes, you, sir.
Yes, what are your future plans?
Okay, so like our project initially started off with us wanting to just help Mr. Riley. So he wanted like something to help fix his glider project, and our initial goal was really just to get him something that would fix it, and we ended up actually making the launcher that we thought would solve the problem. And so like, what do you guys think our future plans would be from that?
Well, since this turned out as such a bigger success than we thought it would be, like fired off with the kids, they just loved it, I think we should actually really take the effort and time in the second semester to try to get that to other schools. I feel like that'd be a good idea.
Yeah, definitely. I mean, we still have some flaws with the launcher, but I feel like if we keep improving and trying to fix what problems we have, it'll be a huge success.
Yeah, we have Mr. Ritter, that is, like helping us all the time. He's willing to work with us for sure. Matt here can refine the whole box itself, get that more compact, and
Yeah.
that's where we see this going.
Yeah, we could probably redo the design because, I mean, let's face it, just a bunch of wood put together. So we can make it always look better and then finalize, polish it up.
Yeah, I think we have plans to like make it out of metal and try to make it lighter and simpler to use. Like the electronics would be something where you just turn a dial or something and it's just ready to go. Like there's no plugging in all the alligator clips and getting everything set up and ready to go. Like you just hit a button and it's good. Right?
Well, yeah, I mean, if you watch my interview, you would clearly hear me say wood is better than metal because it's easier to use, Connor.
Yeah, but there's new technology coming out all the time, and I think we might find something a little bit better. Let's go talk to Manbeck about that.
Most definitely.
But you can do that yourself.
Oh well, never read it.